Hi, ma'am.
Yeah, sir. Now I'll continue. You become unmute, no?
Yeah, but I'll have to go on mute or else आपको मेरे इधर का disturbance आएगा. मुझे actually I wanted to be unmute because I wanted to guide you about the recording, but you've started it, so not a problem.
Okay, okay. Then you can mute yourself, no, from your end also.
Yeah,
Okay,
not a
sure.
problem.
Then
If
I'll
you
continue.
if you want to talk to me, then you will have to unmute me.
I'll do that. Don't worry.
Yeah.
Yeah. Students, even after knowing that the teacher comes to know that who is doing it, why can't you just stop it? Okay, so my dear students, let us quickly revise what we did yesterday. We spoke about the 3 types of subatomic particles, isn't it? In which we spoke about protons, neutrons, and electrons. And talking about these subatomic particles, the protons has a symbol P, neutron N, electron E minus. Protons and neutrons together are present inside the nucleus and they are called as nucleons. And electrons are revolving around the nucleus and there's a lot of empty space inside the atom. So let us get into detail about these 3 subatomic particles, which can be asked in the form of a definition or a distinguish and a lot of questions. So my dear students, when I talk about electrons, protons and neutrons, talking about electron, like I said, the charge on electron is negative, the charge on proton is positive, and the charge on neutron is neutral. Apart from that, the symbol of the electron is represented by E minus, proton is only P, and neutron is N. All right, neutron is N. Moving ahead, each proton carries a positive charge of plus E minus. This is the electrical charge of the proton, which is represented by plus E, and the value of 1 E is 1.6 into 10 raised to minus 19 coulombs. 1.6 into 10 raised to minus 19 coulombs is the value, and coulombs is the unit which is represented for this electrical charge. Please make sure you make a note of this, that 1 E carries 1.6 into 10 raised to minus 19 coulomb, and each proton carries this positive charge. Just like the proton does, the same charge is carried by electron as well. But in the textbook, as they have not mentioned about the electrons, I have not given it, but protons will also be the same and electrons will also be the same, but for neutron it is no charge, right? Moving ahead, let us talk about the location. Where do we find these electrons? Can anybody help me with this? Where are electrons present? Do you know that? Anyone? No one knows where are electrons present inside the atom? Yes, come on, tell me. Anybody knows? Orbit, Ishan, very good. It is present in the discrete orbits around the nucleus. Very good, Ishan. It is present in discrete orbit around the nucleus, whereas protons and neutrons are present inside the nucleus. And can you tell me the word which I used for protons and neutrons together? Protons and neutrons together are called as, in the previous slide I had explained you this term. What is the term? Protons and neutrons together are present inside the nucleus. Yes, Himani, they are present inside the nucleus. Yes, they went very good. They are together called as nucleons. They are together called as nucleons. And the mass of the electron is 1800 times less than that of the hydrogen atom. Hydrogen being the first atom, which is the smallest of all. And imagine the mass of the electron is much more smaller than that of the atom. And that is why we say it is almost negligible. Whereas the mass of proton is 1 Dalton, it is 1 U. U is the units to represent the mass of this electron, protons and neutrons, and this U is given the term Daltons. 1 U is represented as 1 Dalton. Accordingly, 1 U, the value in terms of kg, because we have not studied about Daltons, we have not studied about Daltons, right? We know about grams and kilograms. So 1 U, the value is 1.66 into 10 raised to minus 27 kg. And when I use the word negligible, it means it's very lightweight. It is so light that the weight cannot be taken into consideration. That is why we say the word negligible. And whereas in case of proton, it is 1 U, which is written as 1 Dalton, and the value of 1 Dalton is 1.66 into 10 raised to minus 27 kgs. See, in terms of kgs, it's such a big value. So we don't use such value. We will only write 1 U. Accordingly, my dear students, the mass, just the mass of the mass of one proton is approximately same as that of the hydrogen atom, which is again 1u, and the mass of neutron is 1u again, which has the value 1.66 into 10 raised to minus 27 kgs. Both the values are same, and you also have to remember one thing, students, that the atomic nuclei of all the elements except hydrogen contains neutrons. So this can be asked as objectives in the exam, where they ask you which is the element which is having no neutrons. The answer would be hydrogen. See, this format is not given in the textbook. They have given us different points as nucleus, protons, neutrons, and extra nuclear part. And I would request you all to write this slide quickly in your notebook, so that whenever you are studying this chapter, this slide gives you an overview of exactly what are we supposed to do it in detail. So quickly write it down, please. And for the question, to answer this question, Sneha, discrete means different. One orbit, other orbit, and the other different orbits. That is the meaning of discrete. So this is about the structure of the atom in detail, where we talk about electrons, protons, and neutrons. We know that inside an atom there is a nuclear and the extra nuclear part. In the nuclear part we have two things, which are protons and neutrons together, which are called as nucleons, and the extra nuclear part contains electrons. These are the details about protons, electrons, and neutrons, which can be asked in the form of definition or a distinguished feature or objectives. So you need to know this very much in detail. If you have finished writing, please raise your hand and let me know, so that we'll move ahead with the slide. Few students who had attended my lecture before also, if you don't want to write, it is absolutely fine because you've already written it. Thank you for attending the class again, so that it becomes a quick revision for you people. Out of 66 participants sitting here, only 13 participants have raising their hand. That means you all have finished writing, or you all are just sitting and just logged in and not listening to the teacher. Okay, so now I see a lot of students raising their hands. That means everybody has finished writing this. So now let me move ahead and understand in detail more about electrons. After knowing about the basics of electrons, protons, and neutrons, we also need to know that electrons revolve around the nucleus in discrete orbits, right? They are present in different orbits, that is the extra nuclear part. The orbits being three-dimensional in nature, a term shell is used instead of the term orbit. So sometimes while writing this, I might use the word shell, or sometimes I might use the word orbit. Both mean the same. The orbits are three-dimensional in nature. When I am showing you in the textbook, I'm just showing you the front face, because here I can't show you the 3D image. And we'll use the word shell instead of the term orbit. The energy of an electron is determined by the shell in which it is present. So the number of electrons in the extra nuclear part is equal to the number of protons in the nucleus, which tells me that the electrical charges are balanced and my atom is electrically neutral. So after telling you all these points, after repeatedly telling you about the structure of the atom, if I ask you a give reason stating that what give me the reason why an atom is electrically neutral. Give reason that an atom is electrically neutral. What would be your answer? Give reason why an atom is electrically neutral. Anyone knows the answer to this question? Very good. Few students are raising their hands whom they already know. And for those students who are thinking about the answer, let me give you the answer and just check whether what you're thinking is correct or not. When I ask you the question that is an atom electrically neutral, very good, Devin, the negative and the positive charges inside the atom is always equal. The number of electrons in the answer to the question was already there on the screen. The number of electrons in the extra nuclear part is equal to the number of protons in the nucleus, and neutrons have no charge, which are neutral. So when the positive number is same as that of the negative number, both the charges are balancing each other, and that is why we say an atom is electrically neutral. Is it all right? So from this statement that number of electrons in the extra nuclear part is equal to the number of protons in the nucleus, we can easily conclude that an atom is electrically neutral. Very well. Now, my dear students, I am going to explain you few terms which we have already studied in our lower standards. Let us have a quick recap of this, where I'm going to use the term called as atomic number. The word is atomic number, and atomic number is denoted by the alphabet Z. Atomic number is denoted by the alphabet Z, which indicates the number of electrons or number of protons. Atomic number indicates number of electrons or number of protons. As you can see this structure here, inside the nucleus I have written P is equals to 6. When I have written P is equals to 6, can you see the number of dots which are present in the different orbits of the shell? Different orbits. Can you all see? How many electrons do you think? How many red color dots are shown here? How many red? Yes, 6, right? So when the number of protons are 6, we know that inside an atom, number of protons is always equal to number of electrons. So both are 6, which tells me that the atomic number Z is 6. There is no specific reason behind using this alphabet for atomic number. It is just given in the scriptures, and we are accepting it. Atomic number is represented by alphabet Z, and when I say Z is equals to 6, I should easily be able to answer that the number of electrons is also 6 and number of protons is also 6. So everyone, please write atomic number Z is equals to number of protons or number of electrons. There is no need to draw the diagram. I just want you to write the keywords which will help you understand the chapter. When I say atomic number Z is equals to number of electrons or number of protons. Have you all written? So the term which we are using here is atomic number, which says Z is equals to number of electrons or number of protons. Yes, Kevin, I'll try to do that. Have you all finished writing? So after atomic number, let us take few examples which will help us understand what exactly the atomic number tells us and how are we going to represent it. Let me show you a few more examples here. Now here I have written P proton. This is the first shell. Inside the shell there is one electron, which is hydrogen. So what is the atomic number of hydrogen? If I give you this atom, this structure to you, and I ask you, what is the atomic number of hydrogen? Come on, I want everybody to answer. You can type your answer and show me. What is the atomic number of hydrogen? A lot of students, very good. Very good, very good. So the atomic number of hydrogen becomes 1. And I'm going to write Z is equals to 1. Did you all understand how to be locate the atomic numbers? Let me give you one more example. Nucleus, 2 protons, 2 neutrons, and 2 electrons. And this is the element helium. So what does its atomic number become? What does Z become? Very good. So the atomic number, by looking at the atomic structure, we can easily say it is 2. So helium is Z is equals to 2. Very nice. Let us take one more example. Be quick, huh? 8 protons, 8 neutrons, and in the shell, first shell there are 2, and second shell, as I distribute, they become 6. And the element is oxygen. What will be its atomic number? Come on, give me the answer quick. Majority of you have given me 8, but there are few students who have also written 10. For the students who have written 10, let me clear your doubt. Okay, before that, Saidam, Smitesh, I think everybody is able to hear me loud and clear. There might be some internet issue on your side, so please check why my voice is lagging for you. All others can hear me properly, right? I am audible to everyone. Okay, thank you so much. So let's come back to the question of oxygen, where I discussed that oxygen has 8 protons, 8 neutrons. And as you can see, there are only 8 electrons. It cannot be 10. It is 2, 6. In the first shell, there is 2. In the second shell, there are 6. So the atomic number in case of oxygen also becomes 8. So I'm going to write Z is equals to 8 because 8 protons and 8 electrons, which is indicating the atomic number. Is it all right? So is the concept of atomic number clear to everyone? Once we know about the atomic number, the next thing what we are going to learn now is called as atomic mass number. What is the second thing? Atomic mass number. An atomic mass number is represented by the alphabet A. Atomic mass number is represented by the alphabet A. So when I say atomic mass number, the mass in the structure of an atom, from the work of the previous scientist, my dear students, we studied that the mass of the atom is concentrated in the nucleus. Basically, an atom, the entire mass is present inside the nucleus, isn't it? Nucleus के अंदर पूरा weight है. And what is present inside the nucleus? What is present inside the nucleus? Come on, tell me, what is present inside the nucleus? Yes, very good. Come on, who all are answering? What is present inside the nucleus? Hitesh, your answer is wrong. Kevin, when I say what is present inside the nucleus, no, I am talking about the atom only. Or atom के अंदर क्या present है? That is my question. In atom, there are 3 subatomic particles, which are protons, electrons, and neutrons. And we've studied that the electrons are the lightweight particles which revolve around the nucleus. And the entire mass of the atom is concentrated in the nucleus. So nucleus के अंदर क्या present है? Inside the nucleus, we are having inside the nucleus we are going to have protons and neutrons. Inside the nucleus we are going to have protons and neutrons. So जो mass है, जो weight है, वो किसके वजह से होने वाला है? It is because of protons and neutrons. So mass number becomes the addition of, means atomic mass number is equal to the sum of. When I say the sum means I'm going to add. I'm going to add both the numbers protons and neutrons in the nucleus. Did you all understand? See, you all are getting confused with the terms like atom, molecule, protons, electrons. Let me just have a quick recap of what we have studied till now. In this chapter, which I am talking about, inside the atom, in the beginning, we first spoke about the names of the scientists who helped us understand what exactly is present inside the atom, isn't it? After that, we finally got the structure of the atom after the Niels Bohr discovery was that an atom is circular in shape. In the center, it has something which is called as the nucleus. And outside the nucleus, there are orbits or shells, which are the concentric shells, right? Where were the 4 shells K, L, M, N, which was given by Niels Bohr. So when I use the word atom, we are going to talk about these 3 subatomic particles, which are protons, electrons, and neutrons. And when these atoms combine, we get something which is called as molecules. Are you getting my point? Did you understand the difference between an atom and a molecule? Atom is the smallest particle which is which we are going to talk about. It is so small. You think that work the scientists which they did was easy? It was actually inside the atom. And that great work was done by these scientists, and they helped us understand about this atomic number and atomic mass number. So now we are talking about atomic mass number, which is equal to the sum of protons and neutrons inside the nucleus, which can also be represented as atomic mass number is equals to number of protons plus number of neutrons, which is nothing but P plus N. Is it all right? So now quickly copy this slide, and do not simply copy, read and then write. Please read and then write. I want everyone to write this. Till then, I'll just check what is the problem with my internet if in case my voice is not clear. All right. So now I've checked all the settings from my side. I hope my voice should be very clear to you. And we were writing about atomic mass number. Have you all written this? Please just raise your hand and tell me if you're finished so that we'll move ahead then. And did you understand the difference between atoms, molecules, subatomic particles? This is the basics of chemistry which we are studying in this chapter. So you need to get the basics clear to understand the rest of the chemistry. Okay. So now we have understood two terms from the atomic structure. One is atomic number and the other one is atomic mass number. And what do I say about atomic number? Atomic number, I'm asking again, atomic number. It is either number of protons or number of electrons. And as both the numbers are same, we can also call them as atomic number. When I say atomic mass number is the mass of two things. One is proton and one is neutron. And when I add them both, when I add them both, I get the atomic mass number, that is the mass of the nucleus. After that, we are going to learn how are we going to represent the structure of an atom. Let us see how I'm going to write the conventional symbol of the atom. I want everyone to see the screen properly. The first thing what I'm going to write is the symbol of the element, whatever the element it would be. For example, agar oxygen hai, so we're going to write O. If it's hydrogen, we are going to write H. If it's helium, I'm going to write He, and so on. Whatever the name of the element would be, whose symbol I'll be representing here. Then the atomic mass number, because the alphabet A has come, right? Because the alphabet A has come, which says atomic mass number, will be represented at the top, and the Z, which represents atomic number, will be written at the base. This is the conventional symbol of writing in any element. This you will understand when I give you example. See, the element I have taken here is hydrogen. Now hydrogen has atomic mass number 1 and atomic number also 1. So how do we write it as 1H1? How do I read it as 1H1? And always remember the higher number will be at the top. Now in case of hydrogen, both the numbers are same, so we need not worry. Let us take one more example, carbon. Now carbon is the symbol is C. Carbon, the symbol is C. Atomic number of carbon and atomic mass number of carbon will be represented here. Atomic mass number of carbon is 12, which will be written at the top, and atomic number is 6, which will be written at the base. So now you might be thinking that, ma'am, why are you giving us all this? The question is, in the exam, they might give you this conventional symbol. They will simply give you 12C6, and they might ask you, by looking at the conventional symbol, can you tell us what is the number of electrons? Can you tell us what is the number of electrons? Can you tell me, by the way? Looking at the conventional symbol of carbon, which is 12C6, I am asking you what is the number of electrons. Can you tell me? Very good. I have few students who are answering my question. I've got a lot of different answers, from which the common answer I'm getting is 6. And the students who have written 6, you are absolutely correct. I am asking number of electrons. And for the students who are giving me different answers for them, Devin, a lot of students, Devin, and some are writing Vedika 8. Please listen. I asked you about atomic, I asked you about number of electrons. And when I see the conventional symbol, the number which is written at the top, number which is written at the top is atomic mass number. And the number which is written at the base, which is Z, is atomic number. And from the definition of atomic number, we know that it is same as that of proton or electron. It is same as that of proton or electron. And that is why the 6 represents number of electrons. Is it clear? Is it clear, everyone? Yes, I hope the confusion is clear. To make it more clearer, let me take one more example. And this time the symbol I'm using here is oxygen. Oxygen atomic mass number is 16 and atomic number is 8. Are you all ready for my question now? Should I ask you one question? This time the question changes. You are going to give me the atomic, I'm sorry, you are going to give me the number of protons of oxygen. Number of protons of oxygen. Tell me what is the number of protons of oxygen. Only one student has given me the answer. Okay, now a lot of students are giving me. Number of protons. Again, mixed answers I am getting here. Among which the common one is 8 and the 8 one is correct. 8 is correct because 8 is indicating the number, atomic number, and atomic number is same as the number of protons or number of electrons. तो अगर मैं electrons पूछूं तो भी आंसर 8 होगा, और अगर मैंने protons पूछा तो भी आंसर 8 ही होगा, because both the numbers are same. All right, did you all understand this? Why did we get the answer as 8? Did you all understand this concept? So now let me ask you a tricky question. Now one tricky question which only those students will understand who have understood. Help you with that only. Looking at the conventional symbol of oxygen, which is 16O8, will you be able to tell me what is the number of neutrons? What is the number of neutrons? Advika has already given me the answer. Ved, Prachi, Ishan, Gargi, Gaurang. Okay, very good. A lot of students are telling me the answer. But again, I am getting different answers here. I am asking you number of neutrons, and also type if you can. How did you get the number of neutrons? How did you calculate the number of neutrons? For the students who are getting 16 or for the students who are getting 8, can you tell me how did you calculate the number of neutrons here? Advika, very good. See, from the definitions of atomic number and atomic mass number, we know one thing. We know one thing, that atomic number is the number of protons or electrons, and atomic mass number is the total number of protons plus neutrons. So if P plus N is 16, P plus N is 16, and I already know that P is 16, so we have to subtract. Let us see how we are going to do that. Let us see the question here. To get that answer, let us see the question here. When I say P is, now let me take another example. When I say P is equals to 2, electrons will also be 2. And neutrons number I am giving you 2. So can you tell me what will be the atomic number here? What will be Z here? I am asking atomic number, huh? You can write both the answers if you want. Atomic number also, atomic mass number also, if you know both. Atomic number would be 2. वेरी गुड. वाई इट विल बी 2? क्योंकि जितना प्रोटॉन है उतना ही इलेक्ट्रॉन होगा, उतना ही एटॉमिक नंबर होगा. And atomic mass number, and what would be atomic mass number? Now lot of students are giving me the correct answer. Very good. It is going to be 4. Very nice. Next one. अगर P 6 है तो E कितना होगा? E. Come on quickly. We have to be quick here. If P is 6, how much is E going to be? Very good. E is also going to be 6, and N I am giving you is 5. So now can you tell me what will be Z? These are the details given to you of P, E and N. What will be Z? Z will be how much? Very good. Z will be 6 again. And what will be A? What will be A? A will be, why are you giving me mixed answers now? Come on, think. How do we calculate A? A is going to be P plus N. And P I have here is 6 and N is 5. So in total it becomes 11. Very good. Again, for students who are not able to get it, it's all right. Let us see one more example. Let us see one more example. E will again be 1 and N I am telling you is 2. Come on, quickly tell me what will be Z and what will be A. What will be Z? Very good. Z is 1 again. And what will be A? Very good. Now all the students are able to give me the correct answer. So you've clearly understood the concept of atomic number and atomic mass number. Now, as I was discussing in the previous slide, that how are we going to calculate the number of neutrons? To calculate the number of neutrons, I want everyone to write this formula, which is neutron number is equals to atomic mass number minus atomic number, which is equal to N is equals to A minus Z. Please write this, everyone. If they in the exam they ask you to calculate the number of neutrons, you can directly use this formula which says neutron number is equals to atomic mass number minus atomic number. So N is equals to A minus Z, where A is the atomic mass number and Z is the atomic number. Have you all finished writing? Have you all finished writing this? Very good. And Gargi, very nice. I'm very happy to hear that you've got full marks. So with this, many questions will be asked to you in the exam. For example, if you've understood the concept of atomic number and atomic mass number, let me ask you one question. If the atom has atomic number 20 and atomic mass number 40, and if the element is calcium, how are you going to write the conventional symbol? I'll repeat the question once again. This element which you're going to use is calcium, and the symbol of calcium is Ca. It is Ca, and the atomic number of calcium is 20 and atomic mass number is 40. How are you going to write it? Sanskruti, very good. Your answer is correct. Yes, Ishan, very good. Sorry if I am spelling your names wrongly. Nick Candro, you're also correct. Very good. Shreya, very nice. Okay, for those students who did not understand my question, let me repeat it once again. I am giving you the element is calcium, and calcium has symbol Ca. Okay, and you are going to give me the conventional symbol of it. Calcium is Ca, atomic number is 20, and atomic mass number is 40. Advika, very good. For Deepika, how are you going to write it? It is a conventional symbol. If you remember, I showed you in the previous slide. See, I'll show you once again. See this one. This is the types of conventional symbols. So your answer would be 40 Ca20. Always remember, atomic mass number will come on the top, and at the bottom atomic number will come. The higher value will be on the top and the lower value will be followed below. So the answer would be 40 Ca20. I hope, Deepika, you've understood this now. How are we going to write the conventional symbol? See, this is how you represent the conventional symbol. I gave you the name of the element. It may say sub details I provided you. I told you what is A. I also told you what is the element, and I also told you what is Z. So the A is the atomic mass number, which was 40, which I gave you. Element is calcium, which I told you. And Z is the atomic number 20. All these details will be given to you in the exam. You just have to show the representation like it is shown here as 1608. जैसे 1608 लिखा है वैसे you are going to write the answer as 40 Ca20. Is it all right? Yes, Deepika, 40 Ca20. This is how you're going to write it. Okay, sorry for the break, students. Now let us continue once again. We spoke about the conventional symbol, and we also understood how to calculate the number of protons and number of electrons. Now we are going to understand how the electrons are being distributed. So the next topic which we are going to learn today is called as distribution of electrons. The next topic which you're going to learn today is distribution of electrons. This is very important and little more attention I'll be requiring from all of you. To understand this distribution of electrons, it is as per the Bohr's atomic model. Electrons revolve in stable shells, right? These shells have definite energy. The shell nearest to the nucleus is the first shell, definitely, and the next shell will be the second shell, followed by the third shell. And the ordinal number which I'm going to use for these shells are n. The shells are referred to as the numbers K, L, M, and N. These are the four different shells which are K shell, L shell, M shell, and N shell, which are given the ordinal number as 1, 2, 3, and 4. According to Bohr's atomic model, if you remember, I had shown you the diagram where in the center there is a nucleus and there are four different shells surrounding the nucleus, and these four shells are K, L, M, and N. and accordingly the K becomes 1, L becomes 2, M becomes 3, and N becomes 4. And we are going to make use of the formula of 2n square to understand the maximum number of electrons the shells can accommodate. So if the magnitude of n increases, the energy of the electron in the shell also increases. Now let us see. If you all can see this diagram, can you see this picture on the screen? So here I have given you the 4 different shells. Okay, now you are going to answer me one by one quickly. K, the symbol is K, N is 1. I am using the formula 2n square. So what will be the number of electrons? What is 2 into 1 square? The answer as 2. Very good. So the maximum capacity, the maximum number of electrons which can go in the first shell is only 2. You cannot put more than 2 electrons in the first shell. This table is there in your textbook on page number 32. If you're having your textbook with you, you can directly write the answers in the textbook itself. And if you're not having the textbook, you can write all this in your notebook. The next one is the L. Number of shell is 2. So with the formula 2n square, it will be 2 into 2 square. So what will be the answer for 2 into 2 square? It is 2 into 2 square, Devin. 2 square is 4. So 4 multiplied by 2 is going to give me 8. So the maximum number of electrons which the second shell can accommodate is 8. It cannot be more than 8. Third one, M. M, the ordinal number is 3. So the formula which I'm going to use here again is 2n square. Very good. A lot of students are already answering this. It is 2 into 3 square. First of all, what is 3 square? 3 square is 9 and 9 twos will be 18. So we get the answer as 18. Fourth one, N, 4. So for 4, how are we going to write? 2 into 4 square, which is going to give me the answer as 32. Very good, students. So the maximum, with the help of this table, we are able to understand the distribution of electrons, which is also called as electronic configuration. Which is also called as electronic configuration. And you might be thinking, ma'am, is there any more shells apart from KLMN? Yes, there are more shells which we are going to study only in higher standards, not for even till standard 10. We are not going to learn more than 4 shells. So you need to concentrate only on these 4 shells and their individual capacities. The K is going to have 2, 8, 18 and 32. And I assume that everybody has written this in your notebooks as well and your textbooks. Have you all written the maximum capacity a shell can accommodate? Okay, very good. So understanding on the similar lines, we have seen that 2, 8, 18, 32 electrons can be accommodated in the shells K, L, M and N respectively. This is the maximum capacity they can accommodate. They cannot put more than any other electrons. This shell-wise distribution of electron in an atom of an element is called as the electronic configuration of the element. What it is called as? Electronic configuration of the element. Each electron has a definite energy as per the shell in which it is present. An energy of an electron in the first shell is the lowest. Similarly, energy of the electron in the subsequent shells goes on increasing with the ordinal number of the shells. Here the important point which you need to remember, or you can even write it down, is the third point, which is the definition of electronic configuration. The shell-wise distribution of electrons in an atom of an element is called as the electronic configuration. In the exam, they might ask you what is electronic configuration, what is the individual capacities, how many electrons can be accommodated in these 4 shells, and what is it called as. It will be called as the electronic configuration. And when I say the word electronic configuration, it is simple the distribution of electrons. Let us see how electrons are distributed in different shells here. Now I want everyone to see the textbook, that is page number 33, or you can also see here on the slide, I am having this table 5.7. The first example, the first 3 examples are already solved for us, where the first example, atom hydrogen, symbol is H. H, the electron number in the atom is 1. When it is having only 1 electron, that 1 electron is definitely is going to go in the first shell, which is the K shell. So the electronic configuration also becomes 1. Helium has 2 atomic number, and the first shell, that is a K shell, has the maximum capacity 2. So I'm going to put those 2 electrons there only. So the electronic configuration again becomes 2. For lithium the atomic number is 3. when the atomic number is 3 and in the first shell I can only put 2. So from 3 when I put 2, remaining 1 will go in the next shell. So the last column helps us to understand how electronic configurations are written in the numerical form. So it becomes 2 comma 1. Now for carbon, which is 6, can anybody tell me how will I write for carbon? Very good, Himani. I'll explain once again, Mithul, do not worry. Listen. So for carbon, let me give you the answer so that the students who have not understood will understand this. Now for carbon, the K shell, we have to see, I am going to write the electronic configuration. और electronic configuration का मतलब होता है shell wise distributing electrons. In front of me, I have 4 shells. First shell can only accommodate 2 electron, right? So 6 में से first shell में I am going to put 2. So how much I'm going to put in the next shell? 6 में से जब 2 चला गया तो और कितना बचेगा? It's going to be 4. So the electronic configuration becomes 2 comma 4. Did you all understand how did I write this? It becomes 2 comma 4. Now I hope everyone is clear with the concept of electronic configuration. Even if not able to do it, try to do the next one, which is nitrogen, which is having 7. अगर 7 atomic number है तो first shell में how much we can put? Yes, very good. Sanskruti, Deepika, Deven, Advika, very good. You all are getting the correct answer. Yes, Mithul, first shell is correct. First shell is going to get 2. So how much I'm going to put in the next shell? Very nice. In the next shell, I'm going to put 5. So it becomes 2 comma 5 and that becomes my electronic configuration. Very nice. I think everybody has understood. So let us move ahead faster. Oxygen 8. How will you split oxygen? You can directly give me the electronic configuration. Even if you don't give me 1 shells, it is all right. You can give me directly the electronic configuration. Very good. It becomes 2 and 6. So the electronic configuration becomes 2 comma 6. Is there any student who is still not able to understand? Can type and let me know that ma'am I'm still facing difficulty so that I'll explain the concept once again. So for fluorine, which is 9, I'm already getting answers for fluorine. Very good. The first shell will contain 2 and from 9 when I put 2, the next shell will contain 7. So the electronic configuration becomes 2 comma 7. So the electronic configuration becomes 2 comma 7. Who's going to answer me for neon now? Neon, very good. Neon is first shell 2, second shell 8. So the electronic configuration becomes 2 comma 8. Very good. Let me see how many of you are able to do it for sodium as well. Wow, already a lot of answers. Yes, Mansi, what happened? I'm not able to read any question from you. Can you please type and tell me what doubt you are having? Okay. So for case of sodium, Ramandeep JB Nagar, listen, you've distributed it in a little wrong way. That in the first shell you put 2, right? That is correct. That was the maximum capacity. But the second shell has a maximum capacity of only 8, right? So you cannot put 9 there. Even though from 11, I want to put 9. I can't do that. I can't do that. So I will have to put 8 in the next shell and I can only put 1 in the next shell. Did you understand? Because the capacities have become full. Because the capacities have become full, so I cannot put more there. So the splitting happens in this way, that is 2 comma 8 comma 1. Did you understand, Ramandeep? Very good. So now everybody has understood it is 2 comma 8 comma 7 and I'm already getting answers for the next one. That is chlorine, which is 17. So tell me what will be for chlorine? First shell 2, second shell 8 and third shell 7. Very nice. It will be 2 comma 8 comma 7. Very good. So let us do quickly for argon. 18, 2 comma 8 comma 8. Very nice. 2 comma 8 comma 8. Come on, bromine. Who's going to tell me for bromine? How are you going to distribute this 37? Anyone? I want the entire electronic configuration. Nicandro, very nice. Manmeet, see the third shell, no? You've given 25. Third shell ka maximum capacity is only 18. No, you cannot put more than that. Yes, Ved, very nice. Himani, correct. No, Himani, little mistake. Please check. Tanishka, okay, right. Okay, as the answers are moving very quickly, I'm not able to read for everyone. So now you check on your own whether you've got the correct answer or not. The first shell is going to accommodate only 2. The second shell is going to accommodate 8. And the third shell has maximum capacity only 18. So I can't put more than that. So after I see 18, 8 and 2, the remaining number is only 7. So the electronic configuration becomes 2, 8, 18, 7. I hope everybody was able to understand this electronic configuration, and you were also able to understand to distribute the electrons in different shells. Clear? Everyone, is the concept clear to you? Thank you, Atharva. Very good. Because this is, this is going to help us in the future also, where we are going to study about how to represent a chemical reaction. But before that, atoms form chemical bonds by using electrons in the outermost shell. This topic you need to remember. How does a chemical reaction takes place? It is basically the number of electrons are participating in the shell, and the electron which is present in the last shell participates in a chemical reaction. And valency of an atom is determined by the configuration of its outermost shell. The number of electron in the outermost shell will be called as the valence shell. The number of electron in the outermost shell will be called as the valence shell, and the electrons will be called as the valence electron. So can you help me and help me with the answer that what do you think is going to be the valence electron in case of sodium? What will be valence electron in case of sodium? Yes, Mansi, I'll get back to you. Do not worry. What will be the valence electron in case of sodium? Very nice. It is 1. What is the valence electron in case of bromine? What is valence electron in case of bromine? 7. Very good. What is the valence electron in case of hydrogen? Yes, it's 1. So valence electron, no, it's 1. It is the number of electron which is represented in the last shell. So last one. What is the valence electron of nitrogen? Valence electron of nitrogen. Anshul, it is 5. So valence electron of nitrogen is 5. So I think valence electron concept is clear. Now let us try to understand this important term valency. Valence electron was only about the number of electrons present in the last shell. Now the most important part of the chapter which says valency, it is nothing but the shell wise it is the combining capacity of the element. It is the combining capacity of the element. This is the definition. But what does exact meaning of definition mean? When the atom has to become stable, it should achieve 2 important states. The important stable states are 2 electrons in the first shell or 8 electrons in the next shell. 2 electrons in the first shell or 8 electrons in the next shell. These are the 2 stable states. When it is going to have 2 electrons in the first shell, it is called as the duplet state. And when it has 8 electrons in the next shell, it is going to be called as the octet state. Is it clear? 2 electrons in the first shell is the duplet state, and 8 electrons the next shell is going to be called as the octet state. I want everyone to write this down. Duplet means 2 electrons, and in bracket please write only for the first shell. Only for the first shell it is going to be duplet. Apart from that, जितने भी next shell है, जैसे K के अलावा L, M, N, if they have 8 electrons in the last shell, they are going to be stable, and it is called as the octet state. So these are these 2 stable important rules which are going to tell us the stability of the atom, which is also termed as valency. So valency is the combining capacity of the element, and where we discussed about the stable states, which are the duplet state and the octet state. Have you all written this much? Did you all write this? All right. Now, these 3 elements, which are helium, which is having 2. Helium, which is having 2 electrons. See, 2 is the duplet state. नियॉन का फर्स्ट शेल में 2 इलेक्ट्रॉन है, सेकेंड शेल में 8. एंड फॉर आर्गॉन, फर्स्ट शेल इज 2, second shell is 8, and the third shell is 8 again. So the electronic configuration for helium becomes 2, for neon it becomes 2 comma 8, and for argon it becomes 2 comma 8 comma 8. Brithul, now from these three examples, that is helium, neon and argon, we have already seen that they have already achieved their duplet and octet state. They have achieved their duplet and octet state. So they are completely stable. They are completely stable. They are not in need of any electrons. So elements having completely filled orbits or shells are called as free state or stable state, or inert gases or noble gases. I want you all to remember this topic when I'll be doing my next class, that what is the meaning of valence electron, what is the definition of valency, and what is the meaning of this free state or noble state. And which are the two important stable states? They are duplet and octet. And when I say duplet, it means 2 electrons in the first shell. When I say octet, means 8 electrons in the next shell. And I'll be winding up my class here. And in the next class, whenever we are meeting, we'll move ahead and understand the topic of valency in detail. I hope everybody understood today's lecture. I hope all my students have cleared with the concept of valence electron and electronic configuration, because the next lecture when we'll be discussing, we'll be talking about valency in detail. And yes, a very happy Independence Day to all my dear students. I know I am the last to wish you. And Mansi, will you please write down your doubt, whatever you're having, so that I'll clear your doubt and then we can end the class. Others can leave the class. It's absolutely fine. We have done with the lecture today. Others can leave this meeting. Yes, please.